Hi everyone. So I am a fan of Minecraft. I have been playing Minecraft since the beta releases. I think I started playing it sometime in 2011 or 2012. I don't remember at this point. So needless to say, I am a fan of the game. And one of the things that has always bugged me a bit is that coal exists in Minecraft and it exists in real life. Gold exists in Minecraft and it exists in real life. Even most of the animals exist in real life as well. The one long-standing feature of the game that does not have a real life counterpart, except for, creepers and giant spiders, I guess, is redstone. Redstone, for those of you who do not play Minecraft, is it's a powder that you can mine in the game, and it can be used for all kinds of electric circuits and devices and light generation. There is no real life material that perfectly matches redstone's properties. That's something where it can start spontaneously generating electricity that doesn't exist in real life. But it got me thinking, what is the closest thing in real life to redstone? And uh, the answer is very surprising to me because I had to come up with some, insane uh, logical leap to do it. But uh, I figured that I would share my findings with the world. So, disclaimer. Um, oh God, disclaimer. This is not a serious video. This is not or rather, this is not a scientific video, okay? I make gigantic logical leaps in this video. I oversimplify things, and the reason for that, the reason why I'm oversimplifying everything is not because I don't feel confident enough in the chemistry behind these materials that I'm going to discuss. It's that there is literally nothing in real life that even comes close to the properties of redstone. So I have to tweak a lot of real life physical laws and properties in order to get something that vaguely matches what what exists in the Minecraft world. Because the Minecraft world doesn't follow real physics, you know. You can't just dig straight down like that. You can't, if you break the bottom block of a tree in real life or the bottom meter of a tree, the whole thing doesn't stay floating. So bear with me here. I tweak a lot of physical laws and properties, and I make huge logical leaps. This is going to be the complete opposite of some of my other videos where everything is pure hard science and facts. So that's just a quick disclaimer. This is just for entertainment purposes. It is not a scientific video, but we still go into some science here, some physics, some chemistry, some material science. So I still hope that you enjoy it and that you find you learn something from it, hopefully. But just remember that this is not intended to be a science lesson. There are just some aspects of science here that you might be able to learn. Okay, without further ado, I was talking a lot in that intro. Let's start talking about redstone. So some hints. Okay, very obviously it's red. This might be important in figuring out what it is, what its closest real life counterpart is. It's underground, not super useful. Most minerals will be in the crust, but could be useful. Uh, if you mine redstone ore, as you can see in this little GIF down here, it glows a bit, and that might be useful. Those of you who know um, a little bit about luminescence might be able to figure out what property redstone has based on that. And then finally, this one I've never noticed before researching this video because I play with particles off because my computer is a little slow. But apparently, if you have an activated redstone current, such as this, you have particulate matter going up. That's a horrible arrow. Erase that. You have particulate matter going upward from the block. So like almost like a smoke coming out of redstone. That's not really going to be super useful in its properties, but it will be a little bit useful in me proving my point towards the end. Okay, this one might be a given, but we need to discuss a little bit of what electricity is. And so this is an oversimplification. All of my electrical engineers who watch this might get mad at me for oversimplifying what electricity is. It's fine. This is a video about Minecraft. There's no need to be serious about this. So at its root, at its absolute most basic, your kindergarten explanation, electricity is the flow of electrons from one place to another. Okay, that is the most basic definition of electricity, and it will always go from a negative charge, so negatively charged place, because electrons are negatively charged, to a positively charged region. Where, in other words, there are more electrons here, and there are fewer electrons here. We're not going to go into electrochemistry right now, but this is at its core what electricity is. That's why in your batteries, you have a negative end and a positive end. That's what this means. And so by having this difference in charge across a battery, you're able to get electrons to move from one place to another, and that's how you get current. And so this is your electric current, which is the letter I. So before we move on, one more interesting thing to note is that if you've ever taken a class on electricity at its a basic electricity class, you'll notice that you always take it with magnetism, E&M. Now, I did not like electricity and magnetism. I was not the best at it, but I do know that there's a relationship between electricity and magnetism. So if we have our x-axis here and our y-axis here, and a z-axis going this way, okay, let's say we have an electric field. So these are all sinusoidal curves. I'm going to show this in red. Let's say we have an electric field going this way, right? So it's moving in the x direction. You are always going to have a magnetic field perfectly orthogonal to it going in in a perpendicular direction to it. And so that means that electricity and magnetism are related to one another. They are one and the same. And so wherever you have electric field, you will have magnetic field. So I'm going to stop there as to not complicate things. But to put it simply, whenever we talk about electricity, we must also talk about magnetism. Okay, so that's a brief primer on electricity. We're going to move on before I start talking too much about physics. I am not a big fan of physics. So these are some screenshots from various places. I'm not going to read them all. Long story short, everyone on the internet has it wrong, and we're going to see why as we move on with this presentation. So the first key clue that we have is that redstone has a property called piezoluminescence. What does that mean? It means that, well, let's talk about luminescence first. So let's say I have, I don't know, I don't have a script with me, guys. I'm ad-libbing this. Let's say we have I don't know. Okay, let's say we have a sheet of green material. This is green material, and it glows, right? Well, we can say that this by itself has luminescence. I can't spell. Luminescence, that's a C. That's an E. That's horrible. You rewrite that. Luminescence. I can't spell today. It can glow by itself. It can emit light. And light, just like electricity, is a flow of electrons, except in the case of light, what you have is, so again, the atom does not look like this. But you might have learned the orbitals of atoms. So if this is your nucleus, which is positively charged, and you have an electron here, and it drops to a lower orbital, you're going to see a release of energy, and that will come in the form of light. So HV, that's light. Now, sometimes you will have very rare materials, or not rare, rather, as you'll see, but very unique materials in which if you apply pressure, so let's say, I don't know, redstone, let's have it some red sheet here, and we took a hammer or something and we applied pressure to it, well, that would disrupt the atomic structure of this material enough so that you'd get electrons to drop energy levels, and that would release light. But it would have to be done under these conditions in which pressure is applied. Redstone matches that description. Remember, we said that if we start mining redstone, it starts glowing momentarily. So we can kind of conclude, half conclude, that redstone has this property of piezoluminescence. It is a luminescence dependent on pressure applied. So this is a horrible GIF. It didn't render properly in PowerPoint. I recolored it a bit. It's from Smarter Everyday, Destin from Smarter Everyday. But you can kind of see, I'm gonna kind of highlight where you have to look a bit. But you can kind of see as this candy is hit by the hammer, you can kind of see some light being emitted. So this is an example of piezoluminescence. And the way it works is, remember that electricity and light is electrons flowing from one place to another. So if we apply pressure to some substances, well, they have these electron domains represented by these red arrows, and these represent the orientation of the electrons in that specific region. And notice how they're pointing in different electrons. They're not going to be able to flow easily. But for piezoelectric substances and piezoluminescent substances, if we apply pressure, we can orient the electrons in a specific direction, and that is how we can get a current to form. So this is piezoelectricity, and other substances are piezoluminescent. So we can get light from this polarization. So very cool property that not too many materials have, as you might realize by now, not too many materials have it. So thankfully, I don't have the list of piezoluminescent materials memorized. That's not something that I do in my free time. Wikipedia luckily does have one, and I don't know if it's a comprehensive list. Probably isn't, but it's probably a pretty solid list. For if there's any PhD material scientist who can comment on this, feel free. But we can narrow it down based on, we can narrow down what redstone is based on the Wikipedia list. So firstly, I don't think that we're getting something completely man-made. We might be able, actually, I don't want to spoil the end of the video, but we don't want anything that we've only ever observed in laboratory conditions, under extreme pressures or extreme conditions in tiny amounts. We want something that can realistically be found in nature. So we can eliminate a bunch of these. I don't expect any of you to know what these are, but if you are a chemistry student, you might be able to name these compounds based solely on their formulas. And I am a student of chemistry. This is my specialty. So I'm going to name them right now. If you are a chemistry student and you want to try this, pause it here. If not, this is, I'm not going to write them out. We don't have the space for that. This is gallium phosphate, lithium niobate, lithium tantalate. This one's a little harder. This is potassium sodium tartrate, and the water indicates that it's a hydrate, so there's some water in the crystal structure. Up next, anything that isn't red gets eliminated. So not many things in nature are super colorful. So if it's not red, it can't be redstone. So this is lead titanate, this is aluminum phosphate. And finally, if it already exists in Minecraft, I'm going to assume it's not redstone. So quartz is piezoluminescent, yes. This is very common. Quartz is in sand, it's in glass, it's in everything. But because it already exists in Minecraft, I'm going to assume that, you know, the Minecraft gods did not make a mistake and have two different kinds of quartz in the game and only name one of them quartz. I'm going to assume they didn't do that. We could just end the video here if it was quartz though. And finally, not enough info, langasite. So that will be the next slide. So this is a material called langasite, and this looks almost exactly like redstone. My drawing of redstone is horrible. Come on, it looks exactly like it. The problem is, this picture is something I took from a shady website that claims to be selling it. So we don't even know if this is what langasite looks like. The other sources that I could find said that it was orange, which I guess this is a little bit orange. Like here, you can kind of see a little orange. I didn't see any info on whether or not it's possible to find this in nature. I didn't see any info on its other properties either. So very sadly, we could end this video here with langasite, but there just isn't enough information, and there's a much more interesting, wacky, shenanigans type explanation for what redstone is if we keep going. But for those of you who want to know what this is called, if in case you want to look more into it, it's langasite. I wasn't able to find much info about it, sadly. So it's at this point in the presentation where we run into a bit of a problem. So we know that redstone is piezoluminescent because when we mine it, it glows. We know that redstone is also piezoelectric because if we apply, oh, I didn't say that, redstone must be piezoluminescent. I'm sorry, I have no script, I'm ad-libbing this. So for example, if we have a button in Minecraft, this is supposed to be a button, and we apply pressure to this button, we get some kind of response from a redstone wire at the other end. If we have a pressure plate, so let's say we have, I don't know, a creeper. Let's just say this is a spider, right? No, it's more realistic. And it steps on a pressure plate, you can have a redstone wire activate. Redstone very clearly responds to pressure with both light and electricity. Or rather the generation of an electric current. And no material on Earth is going to respond with that much electricity, just with that kind of pressure. There's no such thing, but let's play around with that. Crystals can be piezo-luminescent. So, for example, this is topaz, this is tourmaline. They are both piezoluminescent, and most piezoluminescent substances are going to be crystals. But crystals are very bad at conducting electricity. They're very bad, and the reason for that is crystals are usually held together by ionic bonds. So let's take sodium chloride, NaCl. Well, sodium has 1 valence electron. This is where we're starting to get into chemistry. And chlorine has 7. Okay, 7. And what actually ends up happening is sodium wants 8 valence electrons, chlorine also wants 8. There's a more in-depth explanation behind this, but I'm not going to go into that. And so the best way to do that is for sodium to lose its electron, this 1 electron here. It goes to chlorine, so chlorine becomes negatively charged and sodium becomes positively charged, and these opposites attract each other, and you get a very strong bond, and we call that an ionic bond. So ionic bonds are formed when 1 electron moves from one atom to another, and they're held together by their charge differential. So what ends up happening is you actually get these gigantic crystal structures in which, I don't know what this is, in which you start to get these coordination complexes of ions being held to each other in a crystal shape. And that's why crystals often have these repeating structures such as this. So you can kind of see here, you have a kind of outline here. And the electrons are held very tightly in this position. This is called a crystal lattice if you take chemistry. This is called a crystal lattice. And the energy of these bonds these bonds are very, very stable. You're not going to lose electrons. So it's very hard to get electrons to flow. I'm going to show that in red, to flow through this system from one lattice to another. So crystals tend to be very bad at conducting, which puts us in a little bit of a bind because most piezoluminescent substances are crystals, and it's very rare that you'll find something that's not a crystal. So either we have to give up here, which we're not, evidently, because I made this video, or we're going to look for something that is piezoluminescent, but it's not a crystal, very difficult, or we're going to look for a crystal, and we can kind of tweak its properties a bit, and that's what we're going to do. So while looking for an answer, I saw one Redditor who talked about a salt instead of a dissolved salt being the answer. And well, yes, the answer that I came to was also a dissolved salt, but you have to look very carefully. So on the Wikipedia article for piezoluminescence, it says that irradiated salts such as sodium chloride, potassium bromide, and blah 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 these have been shown to have piezoluminescent properties. And I think that this one Redditor, I don't remember what Reddit thread it was on or what the name of the Redditor was, picked a red salt that could feasibly be redstone. I think they picked a cobalt salt and they said it was irradiated, which is fine, I guess, but they're wrong. They didn't read the paper. Remember, if you go on Wikipedia, you want to look at the footnote, see where it takes you, and it takes you to this paper in this case, and note that this paper found this property in alkali halides. So not just any salt, they found it in a few specific alkali halides. Now, brief chemistry lesson here. Your group 1 elements are your alkali metals. So these have 1 valence electron. And over here in group 7, you have your halogens, which have 7 valence electrons. NaCl, which was the example I used previously, is an alkali halide. Your alkali metals and your halogens are very, very reactive because they're only 1 electron away from hitting this glorious 8 valence electrons. And so your halogens and your alkali metals will react very readily with one another to form these compounds, and these are your alkali halides, hence the name alkali halide. So when we talk about alkali halides, we mean a metal from group 1 and a halogen from group 7, or a halogen, because all halogens are in group 7. Okay, so enter our candidate, and this is where this starts to go completely off the rails. Potassium chloride, or one of its old names, more arcane names, is muriate of potash. Okay, so my hypothesis, this should not be, technically, this is a hypothesis. It's not even a hypothesis, this is a guess, but is that redstone in Minecraft is irradiated potassium chloride with trace amounts of iron, and the trace amounts of iron is what gives it this reddish color. This is real potash. And this is a very common fertilizer. It's been used since ancient times. And the name actually comes from pot, as in you grow things in a pot, and ash, meaning you burn it. So what ancient people would do is they would take wood and they'd burn it. And the ash that was left could be further burned and processed into this fertilizer powder. And if you find it mixed with iron, it is reddish. So this looks vaguely like redstone. Okay, I can kind of see the resemblance. And also, we're not going to delve into electrolytes, but because if you put this into solution, so if you were to put it into water, KCl, it would dissociate completely into potassium ion and chloride ion. This is very good at conducting electricity. This is a very strong electrolyte solution. And so it's harder in a solid, but theoretically it would work better than these gigantic crystal structures that are held together. And like I warned you in the beginning, this theory was going to go off the rails. This is just for fun, but bear with me here. Okay, so before I move on, I know this video is getting a little bit long. I don't need this part, but I'm going to include it anyway because it's funny. Physicists, you can close the video now because I'm going to butcher a topic in physics. What about the particulate matter? Like I said, and I know I technically said that, it's not needed to identify redstone, but it would give me the chance to explain a kind of cool topic in physics. So I'm going to take that opportunity. Okay. So we're going to do a tiny bit of calculus here. Don't worry, there's no actual math. It's just a concept, and it's the right-hand rule. So this is a human right hand, and this is vector. So remember that vectors have a magnitude, like a scalar quantity, and a direction. So, for example, if I say I was moving at a speed of 2 miles an hour, you might say, okay, in what direction? And that gives you no kind of information on what direction someone was moving. But if you were to say this person was moving with a velocity of -2 meters per second, that would give you the direction that they were moving in the information that they were moving in the negative direction. That's just the most basic kind of vector. You have all kinds of vectors in physics, but the right-hand rule, so this x here, I know you can't see this because of the background, this is an x, this is a cross rather, we call it the cross product. The cross product is an operation that you can do for vectors, and it's not the same as multiplying, okay, this is not multiplying, not multiplication. This is a special kind of property of operation that only works on vectors, or rather, it works on vectors. So, to sum it up, you take your pointer finger here, as you can see, and your first vector, vector A, you will point your pointer in that direction. You will bring out your middle finger so that it is perfectly perpendicular to your pointer. So this is 90 degrees. And you will point it in the direction of the other vector. So if you're trying to do an operation, A cross B, you're going to orient your fingers, and you have to keep this 90-degree angle, okay? You got to keep that angle, and you're going to try to orient your hand in whatever way possible until you get your A pointing in the right direction and your B pointing in the right direction, okay? This means that if you bring your thumb up, so that, again, this is also 90 degrees. So almost like you're forming a coordinate plane with your hand, or it kind of looks like a handgun almost, then your cross product will always be pointing in that direction that your thumb is in, always. It doesn't give you much information about the magnitude, but it does give you information about the direction, which can be useful in checking your work. And so this is called the right-hand rule in calculus, vector calculus, and it's useful to find the cross product of two vectors. Why is this important? So there is a phenomenon, a law rather, in physics called the Lorentz force law, and it's more complicated than what I'm going to say, which is why I told the physicists to leave. But to put it very, very, very briefly, Lorentz force law states that there is a force that acts upon a current, and its direction is equal to the velocity of electron flow crossed by B, which is the magnetic field. So, if you look over here at the bottom right-hand corner of the screen, we have a redstone circuit that I did not make. I found this on Google Images. And I kind of imposed the right-hand rule onto the redstone circuit. So if we point our pointer finger, our vector A, in the direction of the flow of electrons, well, magnets don't really exist in Minecraft. There are no magnetic fields. But let's say that the magnetic field runs parallel to the ground. Okay, this is not a hard assumption to make. We saw in the beginning, I kind of showed that in the beginning, where you have your X, Y, and Z, and if your electric field is going this way, propagating in that direction, you can easily get a magnetic field in the other direction, orthogonal to it. And so if we look at the direction at which our thumb is pointing, it's actually pointing up. Let me put it in white here. It's actually pointing upward. And this is a force that is acting upon our wire. So if we have laid down a streak that is powder and we apply force upward, well, I don't think it's unreasonable to assume that pushing upward on that powder, you would get this particulate matter floating upward. So this kind of confirms our suspicion that this is a wire pushing electrons in a certain direction. And I don't think the Minecraft devs intended for this to happen, but it's just something interesting, and I'm sure I butchered the topic, but this is not a serious video, like I said. How did it get so far underground? This is a mystery now, because potash, as we said, is it's a derivative from organic compounds. So not compounds, but organic material. So how did it get underground? This is where we start delving into a Minecraft lore theory. So a Redditor by the name of Master Gamer gave a theory for Minecraft lore that I'm going to summarize this in a drawing on the side here. If you want to read this screenshot, you can. In essence, what happened was before the player spawns in the world, there was an ancient civilization of builders, and they are responsible for building all of the generated structures that we see in the game. So your desert temples, which I'm going to draw like that, even your strongholds underground, in theory, is that, I don't know what this is supposed to be. This is supposed to be a stronghold, and the theory holds that these ancient builders are responsible for all of these structures, and that they were all destroyed in some great genocide by something, some theories range from war among the builders to, you know, the wither, and I'm going to draw a horrible wither here. Ooh. Or they got too far with their magic. Wither has 3 heads. Or they got too far with their magic and they did some weird thing. I don't know. So they did something. Everyone has their own theory, but this is a part of the fan-made Minecraft lore, not canon. I emphasize here, not canon, but it does explain something about where redstone comes from. I don't remember why I put this slide up. Oh, this is like my drawing slide. So, if we, okay, so I'm going to draw like ancient builders here, right? And let's say that they had trees, which they did, evidently, and from here they were able to derive potash, which is a fertilizer. So just as we in the current game use bone meal, ancient builders would have used potash, and they would have used it all over their fields, everywhere you go. So it would have been spread out across the world. Now, when the Minecraft ancient building civilization died for whatever reason, whatever tragedy struck the Minecraft world, let's just say that it irradiated the whole world. I don't know, that would explain a lot of weird things, all these mutant creatures. And I know I'm a biology student, that's not how mutations work, really, but you get the picture. So you have these fields of tilled soil with potash in them that were irradiated by some magic force, or maybe they were given magical properties by, I don't know, summoning the wither or something. And over millennia, so millennia later, you start to get them buried deep beneath the earth. So if this is the surface, geological processes happen, and you get your potash mixed with iron, because we know that iron exists in the Minecraft world, deep, deep underground. And I'm going to kind of, not assume, but rather, you know, kind of imply that geologic processes exist in Minecraft because we get coal in the Minecraft world, and coal is compacted material from compacted organic material from the Carboniferous period, 360 million years ago. That's why we call it the Carboniferous, by the way, because we get coal from that layer, so Carboniferous. And I know someone pointed this out to me when I was presenting this to them. Well, if that was 300 something million years ago and coal can be found at the surface, why is redstone found so much deeper underground? Wouldn't these builders have to have been billions of years ago? And to that I say, it's a game. But I think that this could work. So, oh, that's why I had this slide. Oh, yeah. Um, Long story short, an ancient, this is a massive video, but it is a video that exists. So, summary of one Minecraft theory. You know, I already summarized this. Let's move on. Okay, so I'm sorry, this is probably the messiest video I've ever made, but it's okay. So now you might say, well, Justin, maybe the ancient builders did craft potash, but how could they if the player cannot craft it? And to that I say, there are a lot of things in the Minecraft world that were clearly crafted, but the player cannot craft them. So for one, we have the end portal block, we have the gapple, the saddle, and this is a fake recipe, and horse armor. So at least in the at least in the latest version of Minecraft, when I'm writing this video, I'm not writing this video, I'm ad-libbing it, making the PowerPoint for this video, none of these items can be crafted, and yet we can find these in chests, in strongholds, in various places across the world. Someone had to have crafted them, and I believe that the ancient builders did that. But we do not have the recipes as the current player. So it is very possible, in fact, this is proof that the ancient builders had crafting recipes that we did not have access to. And one of these could be potash, which is the precursor for redstone. And from this paper, potash production in northern Sweden, what tree did the pre-industrial peoples of Sweden use? Not pre-industrial, but early 19th century, birch. And birch is a tree that exists in Minecraft. This picture is self-explanatory. So, in conclusion, what is the conclusion that we draw from this unscripted mess? So, in the beginning, there was an ancient race of builders. I think I've did this diagram before. I don't know. I've done a lot of takes of this video. And they cut down trees. This is a tree. Here, let me make this green so you can see that this is a tree. Okay, and from here, they made potash mixed with iron, aka KCl with iron, Fe. Okay, they used this to fertilize their tilled fields with, I'm going to draw a diamond hoe there. And when, I don't know, let's just say they summoned a wither that destroyed them all and also irradiated the world and destroyed everything. Ooh, Minecraft lore over the course of billions or millions of years. I don't know how many years this would have taken. This potash was irradiated, found its way underground, and bada bing, bada boom, we have redstone. So obviously, this is not a real-world analog to anything, except I guess potassium chloride with iron. But it was a wild ride. I mean, I had been thinking for a long time, what could redstone possibly be, if anything? And this was the closest thing I could come up with to a reasonable explanation. As you probably know, this is not reasonable at all. This is nuts. Uh, it's also the best thing I could come up with without being completely boring and just saying, oh, it's red quartz. Um, but yeah, so I have nothing else to say. I am very sorry that I butchered physics and Minecraft lore in this video. Uh, but if you have any comments, if you have any concerns, if you want to yell at me for uh, coming up with nonsense to explain why redstone exists, feel free to put it in the comments. And thank you all for watching.